Hello everyone. Today we will be seeing in detail about the production technology of Sapota. So Sapota is commonly called as chikoo and it is also known as Sapodilla, and the scientific name is Manilkara acras or acras sapota. It belongs to the family Sapotaceae and the chromosome number is 26, and the type of fruit in Sapota is berry, and the edible part in Sapota is the mesocarp, and it is a big tree. It is having long lifespan and it is slow growing. So the scientific name is Manilkara acras or acras sapota. Both are synonymously used. It is belonging to the family Sapotaceae, and the type of fruit is berry and the edible part is mesocarp. It is a slow growing and long lived tree. Here you can see the origin and distribution. It is native to southern Mexico and Central America. Sapota is native to southern Mexico and Central America, and this was introduced from southern Mexico and Central America to the West Indies and then to the Philippines, and from there it was introduced to other Southeast Asian countries. And the commercial cultivation in India was started in Maharashtra in 1898 in the place Galwat, and in world it is grown in India, Philippines, Sri Lanka, Malaysia, Mexico and Venezuela. And in India it is cultivated in various states like Maharashtra, Gujarat. Gujarat is a leading producer in Sapota, then Andhra Pradesh, Karnataka, Tamil Nadu, West Bengal, Kerala, Uttar Pradesh, Punjab, Assam and Haryana. So these are the various states where Sapota is cultivated. So next, here in this slide you can see the composition and uses. It contains a good amount of sugar, carbohydrate, protein, and it is also a good source of ascorbic acid, then iron, phosphorus 27 milligram per 100 gram, then calcium 28 milligram per 100 gram. So this is the composition and composition. So in the next slide we can see the uses. Normally it is used as a fresh fruit, and it is also made into shake, jam, jelly, sherbet and halwa, and industrial glucose and pectin is extracted. Then another important use is the preparation of chicle. Not the preparation, it is the production of chicle. Chicle is the milky white latex of bark and immature fruits. The milky white latex from the bark and immature fruits is termed as chicle, and this chicle is used as a base material in chewing gum and also in the production of statutes. That means small shaped statues are prepared using this chicle. Then the bark contain compound which can be used as tonic, antipyretic and an astringent. Decoction is given using sapota for diarrhea and also in malaria. And in some places tender leaves are used as vegetable. Then wood is also used for making agriculture implements and also used in the furniture industry. So coming to the chicle, here in the picture you can see the white exudation from the fruit. So when the fruits are mature, this white exudates will be absent. So that is also a maturity index in sapota. There will not be any white exudation in ripe sapota. So chicle is commercially, the production is happening in these countries, that is Guatemala, Venezuela, Mexico and Belize. Belize is it is earlier known as Honduras. Then the chicle can be produced from the trunk and also the unripe fruits. As already mentioned, it is used in the making of chewing gum. And this tapping of gum is similar to the tapping of latex from the rubber, and this will be extracted from the trunk and also unripe fruits, and it will be poured into dishes, and later it will be stored or marketed like blocks. Obtained as pinkish to reddish brown pieces, and this contain both rubber and gutta percha. Rubber and gutta percha both are like similar compounds, but gutta percha will be less elastic compared to rubber. So this chicle contain both rubber and gutta percha. Here you can see the varieties, various varieties. Kalipati, there is medium-sized oval-shaped fruits. This is a less seeded with sweet, mellow flesh. Next is cricket ball, that is also termed as Calcutta larch. It is a shy bearer. These are large round fruits and the pulp is gritty and granular. Next variety is Calcutta round. These are large fruits, flesh is gritty. Next is Guti. The fruits are elliptical, small, brown, pulp less juicy, soft and gritty. Next is Pala. Fruits are oval or egg-shaped. And the peculiarity of Pala is that they are born in clusters. Next is PKM1. These PKM series of varieties are released by Tamil Nadu Agriculture University from the research station. So PKM1, these are elliptical to oblong with thin skin. They are rich in sugars. Pulp has a buttery consistency, and this was released in the year 1981. The next is PKM2, that is a hybrid between Guti and Kirti Bharti, released in the year 1992. Next is PKM3, that is also a hybrid between Guti and cricket ball, released in the year 1994. Then PKM4 is a clone from the open pollinated PKM1. That is a little bit dwarf in size, so it is suitable for high density planting, and it was released in the year 2003. The next is PKM5. That is a selection from open pollinated seedlings from a private orchard in Tamil Nadu. They are oval shaped fruits with smooth light brown skin, and the yield is 18.70 ton per hectare. So the yield of PKM5 is so much higher compared to other PKM series. 18.7 ton per hectare is the yield potential of PKM5, and PKM5 was released in the year 2007. Then other varieties, oval. These are small oval shaped fruits, soft, melting and sweet flesh. Then CO1, that is Coimbatore 1. They're released from Tamil Nadu Agriculture University. Fruit shape is long oval, medium sized with sweet taste. Flesh is reddish brown. It is a cross between cricket ball and oval, released in the year 1972. Then next is CO2. Fruits are oblong, round. Flesh is soft and juicy, sweet, gritty. Then released in the year 1974, and it is having a pleasant aroma. Then CO3, this is again a hybrid between cricket ball and Wavella Walasa, suitable for high density planting, released in the year 2000. Then DSH1, so DSH series Dharwad, Society for Horticulture, that is released by University of Agriculture Sciences, Dharwad. So DSH1 and DSH2. So DSH1 is a hybrid between Kalipati and cricket ball. The fruits are round and each fruit will be weighing 200 to 210 gram, and the TSS is 23 degree bricks. The next is DSH2. So this is a cross hybrid between Kalipati and cricket ball. Fruits are oval shaped and medium sized, and the fruit weight is less. Each fruit will be weighing about 150 to 160 gram, and the TSS is 26 degree bricks. So here you can see the variation in the fruit, and also these are the different varieties. Some of the varieties pictures are shown here in this slide. Coming to the climate and soil, this sapota is grown both in dry and humid area, and the optimum temperature range is 11 to 34 degrees Celsius, and above that, if the temperature is above 43 degrees Celsius, flower and fruit drop is observed. Coastal climate is best for the cultivation of sapota. It can be grown up to 1000 meter above mean sea level, and at higher elevation what happens is that there will be chances of frost and winter injury, and it requires an annual precipitation of 225 to 375 centimeter. Soil, it can be grown in variety of soil, but well drained soil is essential. Performs well in deep alluvial soil, sandy loam soil, red laterite and medium black soil. And the soil should not have hard pan at 60 to 90 centimeter. And it can also Sapota can tolerate salt in soil and irrigation water. Then propagation in Sapota. Propagation is done both by sexual and asexual propagation is followed, seed and vegetative propagation. But the problem with the seedling is that there will be lot of variability in the seedlings, and also it will take a longer time for reaching the bearing phase or the flowering phase, since they are normally slow in growth, and seedlings will be much more slower in growth. And in the vegetative propagation methods, different methods are followed like grafting, budding, layering, and also cuttings are also used for propagation. But when coming to the commercial scale, softwood grafting and enarching are adopted as the commercial method of propagation in Sapota. So both seed and vegetative propagation methods are followed in Sapota, and in vegetative propagation method, softwood grafting and enarching are adopted in commercial scale. And for the grafting, various rootstocks are used. So here you see the various rootstock, Kirni or Ryan or Pala, scientifically Manilkara hexandra. So this is the best rootstock for Sapota. So the best various rootstocks are used. Even though various rootstocks are used for the propagation or grafting in Sapota, the best rootstock is Kirni, Ryan, or it is also called as Pala, and the scientific name of Kirni is Manilkara hexandra. This question have come many times in many competitive exams. Then next is Adam's apple, scientifically Manilkara cocci. Then star apple, Chrysophyllum cainito. Star apple, Chrysophyllum cainito. Then meat tree, that is Maduka longifolia, and Mahua, that is Maduka latifolia. So these are many rootstocks, various rootstocks used in the propagation of Sapota. But among this, the best rootstock or the commercially accepted rootstock is Kirni or Ryan, which is scientifically known as Manilkara hexandra. Then softwood grafting. For softwood grafting, we'll be using 6-month-old seedlings. and this gives about 90% success rate. And when there is rain or when there is good humidity, that is July to September is the best month for practicing softwood grafting. And inarching will be practiced in seedlings of 12 to 24-month old seedlings. So here you can see the seed, and these are the picture. It is not clear. Kearney rootstocks ready for grafting. Then season, and the best time for planting is May to June, but we should avoid planting when there are heavy rains. And planting is done in pits of 60 centimeter cube, and the spacing adopted is 80 to 10 meter depending upon the variety. So in this PPT we have discussed about the Sapota introduction, where is the origin, distribution, and also different varieties, climate, and also composition and uses of Sapota. The remaining part will be explained in the next PPT. So thank you.